Here's some homework help on lesson 5.2. This is page 326. It's problem number 38. And the directions are to find f of g of x, and then we're also going to find g of f of x if they exist, and then we're supposed to find the domain and range for each of the composed functions. So I'm going to start with f of g of x. So again, just like we talked about in class, we're going to take the g function and we're going to input it into the f function. So x minus 6 is going to replace both of these x's. So it's going to look like this. X minus 6 quantity squared plus 6 times x minus 6 minus 2. And be careful squaring this binomial. Remember, you square the first term. Then you multiply these two together and then double that, or multiply by 2. So it begins at negative 6x, but when you multiply by 2, it's negative 12x. And then when you square the last, that's plus 36. Continuing on, we'll distribute here. 6x minus 36 minus 2. And now we're going to simplify. So there aren't any other quadratic terms. X squared, negative 12x plus 6x is negative 6x. And 36 minus 36 makes 0, minus 2. Okay, so that is the composite. I'll write it a different way. F of g of x. And now we're supposed to find the domain and the range. Well, remember, this is a quadratic function. The composite is a quadratic, which means that it's going to be a parabola. And the domain for all parabolas will always be all real numbers. It's the range that we're going to have to do a little computing to find. So you can do one of two things at this point. Remember, for a parabola that opens up, like this one does, let's just do a random parabola here, then the range is going to be from whatever the y-coordinate is of this vertex upward, all right, if it opens up. And if the parabola happens to open down, like this case, we would need the y-coordinate here, and it would be all the numbers less than or equal to that y-coordinate. So that kind of gives you an idea of how we're going to find the range in these cases where the composed function is a quadratic. So you've got two choices. You can do the opposite of b over 2a to get the AOS number. So let's just see what that looks like. The opposite of negative 6 over 2, which makes positive 3. Positive 3. And now I can put positive 3 in for x to get the y. Remember, I need the y-coordinate since it's the range. So 9 minus 18 is negative 9, minus 2 is negative 11. All right, so this is a parabola that opens up, and the y-coordinate is negative 11. So just kind of picture, you don't have to graph these, but the point 3, negative 11, I'll just say that's negative 11 down here, is the vertex, and it opens up from here. So all the numbers greater than or equal to negative 11 represent the range. And so we would say it like this, negative 11 and then positive infinity using interval notation. You could also, if you don't want to do opposite of b over 2a, you could change this into vertex form, which in some cases I think is a little bit easier. So remember, completing the square, I just divide by 2, I get the quantity squared, and then negative 3 squared is 9. I always subtract whatever that number squared is, and that shows me that the vertex is 3, negative 11. So I'll let you decide. Do you want to do the opposite of b over 2a, or do you want to do vertex form? You should be good at both, but in these cases you can choose whichever you prefer. So that is the answer to the composite, and then here is the domain and range. And now let's do the other way. Let's do the g of f of x. All right. so this time we're going to be putting the f function in for x in the g function. So x squared plus 6x minus 2, and then minus 6. X squared plus 6x minus 8. That is the composite g of f of x. And once again, we need to find out what the range is. The domain is pretty easy. It's going to be all real numbers. But for the range, let's just do it. We'll do it both ways. Opposite of b over 2a. So x is negative 3 is the AOS, and then to find the vertex, we put negative 3 in for x. So that's 9 minus 18. That's negative 9 minus 8. That's negative 17. So our vertex is negative 3, negative 17. Real quickly, doing vertex form, we would do x plus 3 quantity squared, and then this is 3 squared, which is 9. So obviously, I think that's a lot faster. Plus, it's good practice with changing to vertex form. So since this parabola opens up, a is positive, and the vertex is negative 3, negative 17. Let's just say that this is negative 3, negative 17. So all the numbers greater than or equal to negative 17 will be the range. So we can state the range like this. Negative 17, since it's going to be greater than or equal to, and then going to positive infinity. All right, so that is your full solution for number 38, and number 40, well, number 40 is third degree, so it's going to be a little different. But just wanted to give you an idea of how these work when you're supposed to find the domain and the range for a quadratic function. So, have any questions, let me know.